We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
We have ignition.
हम ज़मीन के रहने वालों की तरफ से आपको खुश आमदीद कहते हैं।
Hola y saludos a todos.
Greetings and friendly wishes to all who may encounter this Voyager and receive this message.
Hello. 안녕하세요. Hello. 여덟 여시마오는 사람. Background attorney. ขอส่งมิตรจิตมาถึงท่านทุกคน Hello เสียงนี้เป็นอะไรล่ะเข้าเวเจ้าทำเกิดกับบ้านเลยเจ้าทำเอา We step into the universe with humility and hope children of the planet Earth.
mga ka-spacers natin out there from Luzon, Visayas, and Mindanao. And sa lahat ng ating mga ka-spacers na nakatutok ngayon worldwide and netwide, magandang araw po sa inyong lahat and welcome to this episode of COSMOQUEST, a podcast. So for this episode mga ka-spacers, we will take a look at the universe as never been seen before through the James Webb Telescope. The James Webb Telescope, mga ka-spacers, is like nothing ever launched into space. It could explore the universe's very first stars, mga ka-spacers, uncover evidence of extraterrestrial life, or literally hit the snag and become worthless. At yun po yung ating pag-uusapan ngayon dito sa episode ng COSMOQUEST. And we have invited Mr. Christopher Lu from the Manila Street Astronomers who will discuss with us the James Webb Telescope. This was part of our webinar series in celebration of National Astronomy Week 2022. So join us mga ka-spacers as we study the James Webb Telescope. And bago po tayo magsimula, please like and share this episode of COSMOQUEST so that we could reach more people. Lalong-lalo na po yung mga estudyante so that they would be inspired and be engaged in the sciences, especially astronomy. Please like and follow us on our Facebook page, the Vedan Society of Young Astronomers. Please like and follow us also on our Facebook page, the Sky Watcher Society of Las Piñas. And please follow me on my Facebook page, the Science Guy Ka-Spacers channel. Also, please subscribe to my YouTube channel, the Science Guy Professor Jun Cajigal. Please click on that notification button so that you would be updated on our future videos. At para po mapagpatuloy itong aming advocacy to share the good news of science and technology to the general public. So tara na po mga ka-spacers and let us now study the James Webb Telescope.
I'm so excited to be here with you all. I would like to thank, before anything else, happy National Astronomy Month, Astronomy Week to everybody. I would like to thank Sir Jun Cajigal and the officers and staff of the SYA, and of course for the students and the teachers and the faculty of San Beda for inviting me to be part of this and to talk about the James Webb Space Telescope. And by the way, in my excitement in making this, in doing this talk, I actually bought myself a shirt. And this, wala lang, adik lang. I'm just, wala lang. I'm just so excited about this scope. Anyway, if you've been following the astronomy news for the past couple of months, you've probably heard of the James Webb Telescope that has been recently launched in last December. And as mentioned before, the James Webb Telescope is the most advanced, the most innovative, the most expensive space telescope to date, right? So you may ask yourself the question, why another space telescope? I mean, don't we have enough telescopes in the world to do observations? And why another space telescope and why so expensive? So, but believe me when I tell you that the hype for this telescope is real. All right, every astronomer, every astrophysicist that has and amateur astronomers as well are all excited about the James Webb Space Telescope. Let me just walk you through as to why James Webb is such an important scientific device. Okay, so let me just share my screen here for a minute. Okay, Yeah, it's the James Webb Space Telescope. As you can see, the design of this telescope is not your conventional looking telescope, no? Like yung pinakita ni Sir Paul earlier, where you see yung telescope is usually encased in a tube, while this telescope has a very innovative design, and there's a reason for that, no? And we hope we get to talk about that a bit later on. So I broke down the presentation into four parts. We're going to briefly discuss the timeline ng James Webb Space Telescope, a brief look into the long and torturous journey from proposal, design, build to launch ng telescope na to. And then letter B, we talk about the launch itself and yung deployment, which means how this telescope unfolded and transforms, like an origami, no? And actually put the Transformers. I'm talking about the toys and the movie. It puts all Transformers to shame. Okay, and part C, we'll be talking about the science instruments that are part of that is part of the telescope itself. And then finally, on letter D, the part D, we are talking about looking forward to the past. See what I did there? Play on words, right? If you're an astronomer and you have an understanding of how light behaves as it travels through long distances in space, you'll be busting a gut right now. Anyway, moving on. Let's talk about the brief timeline of James Webb Space Telescope. So, on September 13 of 1989. By the way, ganito, let's just do a little maliit lang na game. As you know that the James Webb Space Telescope has a 32 years from proposal, build to launch. 32 years ang lumipas. So I'm pretty sure that most of you has your year of birth posted on this presentation, on this slide. So if you see your birth year, just raise your hand. Do it on the chat. Just a little game lang natin. Okay, so let's start. September 13, 1989. This a group of astronomers met in Baltimore, Maryland, in the Space Telescope Science Institute. Okay, and they talked about the next generation of space telescopes. Next generation. So I want you to take note of this. 1989, sila nag-usap of the next generation telescope na magiging successor ni Hubble. Hubble is launched in April ng 1990. So a year before Hubble was launched, astronomers are already conceptualizing the next generation na telescope. What type of telescope would it be? What would it ano yung i-observe niya, and all that. So then in 1996, somewhere in 1996, the next generation space telescope was initiated, meaning nagkaroon na siya ng pondo. And initial na fund na binigay kay James Webb Space Telescope is actually $8 billion. Yun yung initial. In cooperation, of course, with the European Space Agency and the Canadian Space Agency. The Hubble Space Telescope was a collaboration between NASA, European Space Agency, and European Space Agency. Dalawa lang sila eh. But this time, because of this huge endeavor, because of the scope of what James Webb will do, tatlong space agencies na ang nag-collaborate, which is NASA, National Aeronautic and Space Administration, the European Space Agency, and the Canadian Space Agency. Okay, so initial funding is $8 billion. Wow. Okay, so next, in September of 2002, the next generation, the NGST, Next Generation Space Telescope, was renamed to James Webb Space Telescope. Of course, nabanggit na ni Sir Paul that James Webb Space Telescope was named after the director of the Mercury, Gemini, and Apollo missions, James Webb. Yeah. So, and then on September 11 of 2003, the James Webb Space Telescope was awarded to Thomson Ramo Woodridge Incorporated. Okay, now marami din kasi nagpasa ng design of the next telescope to be built. And here are some of those designs na ni-propose. Take a look at these two. See, this is a design by NASA Goddard, and the one is Ball Aerospace. Ito, Lockheed Martin. And ito yung design, finally the design that they thought. Of course, yung nagkaroon ng modifications sa design ng TRW, that's the Thomson Ramo Woodridge Incorporated. Yung design nila Yun ang initial design nila. They nagkaroon ng konting tweaking, nagkaroon ng konting and the design became what it is we see today. Of course, of course, there are other designs bukod dito. Actually, meron nga nag-propose ng next generation na telescope was to be built on the surface of the moon. Gagawa daw ng somewhere in the sa south pole in one of the craters on the south pole of the moon. Merong isang crater doon where sunlight never encounters that part of the moon. So they plan to build a space telescope dun sa southern part ng moon on the lunar surface. But logistically it's difficult, next to impossible to keep and maintain a lunar based na telescope. So continue tayo dun sa timeline natin ulit. So on July of 2011, the James Webb Space Telescope was threatened to be cancelled. Now take a look of yung gap na nangyari between 2003, ilang years siya, 2003 to 2011. Ang tagal, ang daming redesigning, mga design flaws na kailangang i-reassess. Merong mga certain materials, materials na kailangan i-redesign because syempre once again, this is a non-serviceable na space telescope, so it has to be perfect. Once it's built, it has to work perfectly. Ibig sabihin, kaya hence ang tagal nilang ni-design ang mga components nito, all of the heat shielding and the computer software, the writing of all that fits into that 2003 to 2011 na years na kinain ng research and development. So there was a point where certain astronomers or certain investors in this project started asking the question, is it worth it? Is this worth it? But in November of the same year, November of 2011, the James Webb Space Telescope has survived that cancellation. Somehow the investor says, yeah, we should be doing this. We must do this. So nag-push on yung project, and then on sometime in 2012, the MIRI is the mid-infrared imager, was completed and handed off to NASA for installation sa telescope itself. And then on March of 2013, FGS is the fine guidance system ng fine guidance system ni James Webb, at in-install na siya sa ISIM. ISIM is the Integrated Science Instrument Module. And then on July 2013, the MIRI, yung pinag-usapan natin kanina, the MIRI is installed on the ISIM. And then on March of 2014, NIRCam and NIRSpec is installed in the ISIM. Now, NIRCam pala is the near-infrared camera, and the NIRSpec is the near-infrared spectrograph na installed sa ISIM. Okay? And then on February of 2015, the 18 hexagonal segments ng primary mirror is completed. There are 18 na individual na mirrors na ano yun, gawa sa it's not just made of glass. It's also mounted on beryllium struts, and then it was mounted on beryllium struts, and then yung mirror na yun is coated with gold. Kaya kita mo kulay, that yellow thing yung big yellow thing na nakita ninyo dun sa telescope, that's actually gold. Okay. Manipis lang na gold. Why gold? Because once again, this telescope is actually fine-tuned to see infrared light, and gold is a good reflector ng infrared. So gini-coat lang nila yun ng a very very thin coating ng gold. And then then in December of 2015, a launch date was set. The launch date was set on October of 2018, which is, I'm kind of excited about that. Nung time na yun, personally, I was excited kasi the first time I heard about this James Webb Space Telescope was nung 2012 ko na nalaman about James Webb Telescope, and back then excited na ako to learn what of the things that it can do. And then nung sinabi nila na i-launch sa October of 2018, I got excited kasi October is actually my birth month. So it parang for me, parang inisip ko, ang galing parang this would be like a birthday gift ni NASA sa akin. I-launch dito si James Webb Space Telescope on October. So and then on March of 2016, the secondary mirror was installed. Yung nakita yung naka-strut na ito yung salamin ng James Webb. Yung secondary mirror is the one in the tip, yung naka-strut na gano'n. Tapos yung dito sa dulo, ito yung secondary mirror. Yun. So the secondary mirror was installed, and then on November of 2016, the James Webb Space Telescope construction is completed. Buong-buo na siya. Yeah. Now, after nila nabuo yung James Webb Telescope nung time na yun, off to testing. Marami silang iti-test. Vibration test, noise test, all that. Tsaka deployment test, all of that inan nila. They test nila yon just to make sure that nothing goes wrong. No bolts, walang mga bolts na matatanggal, which by the way happened during testing. Kaya one of the things kung bakit na-delay din si James Webb. So moving on, we're at 2016 na, no? Oh, yung mga birth year niyo, don't forget. Raise your hand kung na-mention yung birth date niyo. Then on March 27, 2018, the launch, di ba, yung launch date natin is October of 2018. On March 27, 2018, so 7 months before the launch, na-delay. It was delayed till May of 2020. Ito yung nangyari na in the vibration test, yung isang bolt na nakakabit sa loob ng ng sun shield, isang bolt nalaglag. And then they had to look for the bolt. They have to disassemble some parts para mahanap din yung bolt because that would cause problems pag na-deploy na siya. So they had to redo everything. And then on June 27, 2018, once again, na-delay yung sa May to 2020. Once again, na-postpone na naman siya to March of 2021. Okay, na-postpone siya. Bakit? Ito yung masakit. Yung during the time na tinetest nila yung deployment ng sun shield, one of the sun shield accidentally ripped, napunit, and it caused, syempre napunit yun, you have to replace that, you have to reorder the materials para mapalitan yung napunit na sun shield, and then you have to install it, disassemble and reinstall it, so na-delay siya. And plus, what happened is nagkaroon ng an independent review board once again reassessed kung if it's still worth, if James Webb Space Telescope is still worth launching. Is it still worth sending off to space? Pero when they, so ang ginawa ng independent review board, they reassessed the cost versus the cost, versus the potential discovery and exploration na gagawin ni James Webb Space Telescope. And they assessed na that the exploration and the discovery is well worth the cost. So instead of saying cancel na, ni postpone lang nila yung launch. Then on July 16, 2020, the launch once again was postponed. Once again, on October 31 sa 2021. Once again, I was hopeful again na magiging birthday gift ko ulit ng NASA para sa akin. But that's just me. Dahil sa COVID-19, dahil at this time, kalagitnaan na tayo ng COVID-19 pandemic. And syempre, a lot of precautions has to be made para to keep engineers, scientists, and designers safe from this pandemic. And then on June 1, 2021, the launch again was postponed on November 2021. And then once again, sunod-sunod na yung postponement, delay, postponement, delay. Basically because marami kasing testing na ginagawa, maraming refits and redesigns na ginagawa. And of course, meron din time na nagkaroon ng problema ang software, whereby the James Webb Space Telescope is not communicating well with the Ariane rocket, the rocket where James Webb is supposed to be launched in. So, merong software na hindi sila nagko-communicate ng maayos, so it has to be rewritten and all that. So yan, delay until finally they decide na when everything is okay na, it finally launched on December 25, 2021. That was 12:20 Universal Time, or dito sa Philippines, that's around 8 something, 7 or 8 Philippine Standard Time. Finally, kung binilang nyo kung ilang taon yon, that's 32 years. 32 years, right? Now, to give you an idea kung gaano katagal ang 32 years, yung New Horizons, anybody here heard about the New Horizons probe? That yung probe na pumunta sa planetang Pluto, remember that? The New Horizons probe was launched on January of 2006, and it took 9 years for that probe to reach Pluto. dumating siya kay Pluto July of 2015. Nangyari na yung nangyari na yung launch and nakarating na siya si New Horizons of Pluto. Si James Webb andito pa rin, hindi pa rin nalo-launch. Ganun katagal yung duration ng design, build and launch ni James Webb. And the main reason kung bakit ganun katagal is because they want James Webb Space Telescope, once launched, has to work perfectly. Kasi once again, hindi siya serviceable. Hindi katulad yan ni Hubble na pwedeng puntahan, aayusin lang natin, tighten a few screws, palitan ng mga components, and we're fine. Ito hindi. Because it has to travel 1.5 million kilometers away from the Earth. Okay, and we'll be discussing we'll be discussing that part of the deployment of James Webb mamaya. Okay, so ganun katagal. So then yun din ang reason kung bakit ganun katagal ang pag-launch ni James Webb Space Telescope. So these are a couple of screenshots that it took. Actually, but December 25 to ni-launch. I was nasa ano ako noon eh. At the time I was celebrating, I was with family kasi syempre Christmas. Pero everybody else was watching Netflix, sa Christmas movie sa Netflix dun sa living room. I was in the corner of the kitchen and I was watching this live nung live launch nito nung December 25. And I was smiling at myself and I was really excited ako to see this thing launch. Finally nag-launch siya. And it was the launch was from the launch site from Kourou, French Guyana. French Guianan. Yun yung launch site nito, no? It's malapit sa Brazil. And here's something that you kids could do a little research on. And it's in a form of a question. And ganito yung question ko. Why is it beneficial for launch sites to be closer to the equator? Yun yung question ko sa inyo. Kayo, sige, find the answer. Why is it beneficial for your launch site closer to the equator? Yun. Okay? So once again, balik tayo. So na-launch na siya. This here's the Ariane 5 rocket. Ni-launch siya. And ganito yung itsura actually ng what's inside the Ariane 5 rocket, no? So all this part right here, all this is fuel. Ito yung launch vehicle, and all this is fuel. And si James Webb is on the top. As you can see, si James Webb right here is folded up in such a way to fit sa ganitong configurement, yan, sa ganyang containment, no? They had to design this telescope, which is the size of a tennis court, by the way, to fit sa nose cone, sa payload bay ng Ariane 5 rocket na to. And of course, once it's launched, and then there's mga stages where rocket stages where natanggal yung rocket from the side, and then nag-launch din yung nose part ng yung payload ng Ariane 5. And inside that, once na release si James Webb, yung transformation niya began. Okay? Now I want you to look at this. Yeah. So yung first day ng launch niya, when it was launched on the first day, the first thing na dineploy niya is the sun, yung yung sun array, the solar array niya pala, sorry, yung solar array. This is responsible for for internal power. Siyempre, he'll get solar power and convert it into electricity, and then that gives James Webb its internal power. The next thing na dineploy ni James Webb is yung The second thing na deploy niya is ito. Ito no. Yung this is the yung antenna niya para maka-communicate si James Webb with Earth. Okay? And then on day 3, it deployed its solar shields, yung shield pallets niya. First yung sa likuran niya. First yung likuran, deploy yung back pallet, and then the front pallet yung sumunod. Now, ni-deploy din tong flap na to, tong maliit na flap sa likod. What this does is actually it's a parang stabilizer parang sa mga when you see a car na merong stabilizer sa likod, parang ganyan din yun. Because the sun is giving off yung solar wind. No, not the kind of wind na nadadanasan natin dito. The solar, kung sinabi kong solar wind, I'm talking about ionized particles na nagta-travel through inter-solar system space, no? And this flap actually stabilizes yung si James Webb. Okay? So that's day 3. Then pagdating ng by day 6, by day 6, yung sun shield nag-deploy na or nag-unfold na siya. So yung sun shield starts to stretch left and then right. Ganun. Then on day 7, tinension yung sun shield. These sun shields pala is actually made of some special form of silicone and coated with aluminum. So yung heat that we're talking about, yung heat that's coming from the sun will hit the bottom side. The heat that's coming from the sun will hit the bottom side of James Webb, pero it would never, yung heat na yon will never reach the primary mirror ni James Webb. Kasi all that heat, because of the sun shield, all that heat will dissipate. Yun yung purpose ng sun shield na yan. And there's a good reason why they need that sun shield on the James Webb Space Telescope. We'll discuss that a little later. So nga, na-tension niya na siya on day 7. Tapos there are actually 5 layers. 5 layers yan actually. Yan. Ito pala yung the same sun shield na pinag-usapan natin earlier na napunit. Yan yun. Kasi yung nipis niyan is actually about as thick as a human hair, yung bawat isang layer niyan. So parang kasing nipis lang ng buhok ng kung gaano kalakas yung buhok niya. So ganyan ka-delicate talaga ng yung sun shield niya. Then on day 7, dineploy na yung secondary mirror. So from this configuration na nakatiklop yung secondary mirror, ni-unfold siya like that. That's on day 7, on day 10. And then finally on day 12, nag-extend yung left and right primary mirrors niya. That completes the 18 paneled na primary mirror ni James Webb Telescope. Yeah. So we have a fully deployed telescope. Now I want you to understand something. All this process combines roughly 340 deployment points that has to work perfectly. 340 340 deployment points na kailangan has to work perfectly. Otherwise, if any of those points somehow failed or doesn't work well, the whole mission's off. Ganun ka-delicate talaga. And so you understand na siguro naman you should understand na why it took so long to launch this space telescope, because it has to work one time every time. Okay? Next tayo. Oops. So, yan. We now have a fully deployed James Webb. Okay. Next, it has to travel to a certain special spot in the solar system where it's gonna stay for a very long time. Ito yung sinasabi ko natin na Lagrange point. The Lagrange point. What is a Lagrange point? A Lagrange point is a place. Excuse me. A Lagrange point is a place in the Earth's orbit, where the gravitational pull of the Earth and the Sun cancels out. Ulitin ko the Lagrange points are places in the Earth and Sun system where both gravities of the Earth and the Sun cancels out. Ibig sabihin, walang minimal to zero gravitational force ang meron yung spot na yon. Kaya when you put an object there, it'll just stay there for a very long time. Hindi siya ma-influence ng Earth or ng Sun para matanggal siya dun sa point na yun. Okay. And yung point na yun is yung point na pinuntahan ni James Webb is L2. Yan, itong L2, yung L2. Ito yung pinuntahan ni James Webb Space Telescope, the Lagrange point 2. And this point is 1.5 million kilometers away. So once again, dahil sa distance na to, James Webb cannot be serviced, not like Hubble. So in this graph, nakikita natin how yung paano siya pumasok doon sa how James Webb entered into the Lagrange point 2 orbit. So once again, nag-launch siya from the Earth, and then from here all the way to here, nag-deploy yung telescope. Nag-open up yung sun shield, dineploy yung secondary mirror, and dineploy yung primary mirror. And then on day 25, right here, on day 25, it executed what is called a maneuver 2, or what is called also known as the insertion burn, the orbital insertion burn, where it will make this turn and go orbit around the L2 point, which is here. So ibig sabihin nito, hindi siya stationary dun sa L2, no? Hindi siya mag-orbit na stationary lang sa isang point. Si James Webb is actually nag-orbit siya around dun sa L2. The reason being kasi once again, si James Webb is solar powered. So if James Webb stays in this area, yung shadow ng Earth matatakpan siya, matatakpan, may possibility na ma-cover siya ng shadow ng Earth or ng Moon. So magkakaroon siya ng problem sa power niya. So it has to remain outside this area para makakuha siya ng solar power from the sun. So it has to orbit this area. O orbit siya na gano'n. So if you imagine it, kung na-imagine nyo ito yung Earth, and then nag-orbit siya na pa gano'n, orbit siya na gano'n. So yun yung yung place niya. James Webb is already made that insertion burn and is already orbiting dun sa L2 point na yan. So yeah, success din yan. Success pa rin yan. Next, so let's now talk about the science instruments. Okay, hanggang sa letter C na pala tayo. Let's talk about the science instruments ng ano. So ito, ano lang to, there's a lot of technical stuff, so I'll just go with the yung mga basic things na para malaman ninyo. So we'll start from the bottom going up. Okay, so dito sa baba ni James Webb is the spacecraft bus. What that is basically what that is. That's the navigation ni James Webb. The navigation system ni James Webb. It make this part of James Webb tells James Webb na kung tama ang orbit niya, kung tama ba yung location niya sa orbit, ganyan. So that's basically what the spacecraft bus is. Yung star tracker naman, these are little cameras din. These are cameras na chine-check yung positions ng stars to make sure na si James Webb is located properly dun sa, not just located properly, but to make sure that the observations na ginagawa niya is correct. Ganyan. Or nakaposition siya to make the proper observation. Yan. Yung mga star trackers. And of course, you have the sun shield, the 5-layered sun shield that keeps the primary mirror from away from extreme heat. No. By the way, when we're talking about temperatures, yung temperature differences between the hot part pala itong area na to sa ilalim, and yung cold part yung sa ibabaw. Yung cold part is this yung dito dun sa opposite side, yung temperature dito sa opposite side ng primary mirror, it's about I think 300 negative 300 to negative 350 degrees Fahrenheit. So ganun ka-efficient yung pag-disperse ng heat ng sun shield. And if you're the secondary mirror, and ito yung usapan natin earlier, the primary mirror. So when it finally collects the light from a star, all that observations papasok kaagad sa mga instruments that is located at the back side ng primary mirror. So once again, ang mangyayari dito is that light from a star will come from here, hit the primary mirror, bounce off to the secondary mirror, and the secondary mirror then sends that light into the detector, which is inside this little cone sa center na yan. How Newtonian reflectors work. Actually, each and all modern telescopes today use reflecting telescopes. There are no modern telescopes that are refracting. Kasi mas cheaper to eh. This is much cheaper and much easier to build. And yeah. So, that's how this thing works, no? Basically ganun. That's how James Webb works. Reflecting telescope siya. Or to be technical, dioptric na telescope siya. Ganyan. Or compound telescope, ika nga. So let's talk about the integrated science instruments. And ito yung mga instruments na makikita inside ISIM, yung dinescribe ko sa timeline earlier. First, let's talk about the fine guidance sensor. Fine guidance sensor, no? This ensures that the guide star availability, which means itong guide sensor na to has also a camera that makes sure na kung ano yung ino-observe ni James Webb is right on target. Okay, it's kaya nga fine guidance eh. It centers whatever object ang kailangang na ma-observe ni James Webb Telescope is the near infrared camera, the near-infrared camera. This detects the first light of galaxies and observes galaxies assembly sequences. No? Okay? Tapos yung ano niya, ito medyo technical but just bear with me for a minute. Yung signals na pwede niyang ma-detect yung near-infrared is 0.6 to 5 microns. 0.6 to 5 microns ang nakikita niya na signal na nakikita niya. And then there's the near-infrared spectrograph. Ito naman, once again, near-infrared din siya, kaya ganun din, yun din nakikita niya. 0.6 to 5 microns ang nakikita niya na signal or na light, no? Ganyan. This instrument actually measures the redshift, the metallicity of star formation rates and of first galaxies inside the first galaxies. No, what this instrument does is it takes infrared. It takes the light from a very distant star or galaxy, and then idadaan niya sa prism yun, and then splits that light into its various component colors. Yung tinatawag na spectrum. And ina-analyze niya yung spectrum na yun to figure out kung ano yung temperature niya, kung anong temperature ng object na in-observe, anong temperature niya, ano yung mga elemental components niya, if it's spinning, how fast it's spinning, is it moving towards us or moving far away from us. Yun yung nagagawa ng instrument na to. Yun near infrared, so yung nakikita niyang light is 0.6 microns to 5 microns. This instrument, si MIRI, will actually yung nakikita niya is 5 to 25 microns ang nakikita niya na signal, or yung nakikita niyang light na nakikita niya. Ganun ka sensitive yung itong instrument na to. So all these four components combined, ito yung the integrated science instrument module na nakakabit kay . Now once again, lahat to is mostly made and mostly tuned to observe infrared, near infrared, and mid-range infrared. Okay. Si Hubble was made to see visible light, a little bit of ultraviolet, and a little bit of infrared. Okay? Ganun yung tuning ni Hubble. Yun yung difference ng dalawa. Okay? So if you look at the graph here, ito yung difference ng dalawa. Part D na pala tayo. Looking forward to the past. Okay, ito muna yung difference ng dalawa, ng Hubble and the James Webb Space Telescope. The Hubble Space Telescope has a telescope. Yung primary mirror niya has a size of 2.4 meters. Okay, while the James Webb Space Telescope has a 6.5 meter primary mirror. Okay, so what does this mean? It means James Webb Space Telescope has better resolution, better focusing power than Hubble. Yun yung ibig sabihin yun. Like everything else, no? Pagdating sa telescope kasi, like pizza, bigger is better. Ganun. Okay. So that's why so yung the way yung ika nga ay mas malaki ang gathering light power ni James Webb kaysa kay Hubble Space Telescope. All right? So, excuse me. Sa baba, let me show you this sa baba. Sa baba, this shows the spectrum of light, okay? Part of it is yung nakikita yung red, orange, yellow, green, blue, and indigo and violet. These are yung visible spectrum ng light. Okay, Hubble is tuned to see yung visible light, yung part na to, itong part na to, from here to here, yung visible light, and a little bit of ultraviolet, and a little bit of infrared. Ito lang yung nakikita niya. Ito yung part of the spectrum na nakikita ni Hubble Space Telescope. Meanwhile, si James Webb Space Telescope cannot see visual light. He's not tuned for that. Yung instruments niya is tuned to see near infrared to mid-range infrared. Ito yung mostly nakikita, yung mga nakikita yung madidetect ni James Webb. So what does this mean? What does this mean actually? First part, because of the size difference ni Hubble at saka ni James Webb, here's a simulation, initial simulation ng mga astronomers kung ano ang makikita ni James Webb versus kay Hubble Space Telescope. The image on the excuse me. The image on the left, yan yung simulation of Hubble observing a quasar. Okay? This is at, nakikita nyo sa baba, 0.5 microns. 0.5 microns, no? Ito lang nakikita niya. Yung quasar na in-observe niya, ito lang nakikita niya. Hindi niya masyadong kita yung inside ng quasar. While si Hubble, because of its large primary mirror, bigger primary mirror, at 1.6 microns, nakikita niya actually yung pinaka quasar itself. Hindi lang just a fuzzy image, but nakikita niya yung quasar itself. Another comparison is ito naman is a wider field, no, of the same quasar. Webb could actually not just see the outer parts of the quasar, which is ito yung mga dust particles and nebulosity ng quasar. It can actually see the quasar itself right in the center. Ganyan. So ganito yung resolution power ni James Webb versus kay Hubble. Ganyan siya has that focusing power ni James Webb. So that's comparative sizes, yung size ng So ngayon, how about yung spectrum? Paano naman yung spectrum? Ito yung, if you take a look at this, and if you follow me for a while, this is if you know about infrared, the way you detect infrared, you have to realize that to see infrared, yung infrared kasi is very, very dim na light yan. And it's far away, so far away. Not only that, but the object that you're actually observing is also moving away from you at the same time. So, since napaka-faint niya, napaka-faint niya, you need to have an instrument that has a low temperature para ma-detect mo yung light na yun, yung infrared light na yun. Pero at the same time, ito yung maganda dito. If you can detect far off light in infrared, you're actually looking at an object. You're looking at an object back in time, because the farther an object is, farther the object is, the farther back in time that you're actually seeing that object. Okay, so basically, when you're doing observations on your telescope, you're looking back in time. Okay, so ito yung comparative reach, ng observable reach ng Hubble versus ni James Webb. Si Hubble could actually see all the way hanggang this far from yung modern yun. Hubble is able to observe mga modern galaxy formations. Hanggang dun lang yung limit niya. Ito, yan. Yan. Hubble can only see modern galaxies forming. Kasi hanggang dun lang yung limit niya. Hanggang dun lang yung makikita ni Hubble Space Telescope. Yes, Hubble can see infrared, pero not enough. Just parang pinatikim lang tayo. Konti lang ang nakikita niyang infrared. But compare that to James Webb. He could actually see the first galaxy formations. We're talking about mga 200 million years after the Big Bang. These are early formations, mga first galaxies, first stars, maybe even first planets na form. So these are yung mga observations na gagawin ni Hubble once fully operational na siya. Okay? So this is the part na gets all astronomers excited, mga astrophysicists. This is the part where they get all excited about to see galaxy formations, yung first galaxies that ever forms, the first star that ever forms, the first everything actually, the first everything in the universe na nabuo, ma-observe ni James Webb Telescope kahit ganun na siya kalayo. So that's why we're all excited. Basically, what James Webb will do after all its observations, James Webb will actually rewrite our knowledge of the universe. Everything that we know about the universe right now could change because of the observations and discoveries na magagawa ni James Webb Space Telescope. That's why people, you remember kanina sa timeline that na ni-review ng NASA and ng review board si James Webb Space Telescope twice, and they still figured na it's still worth kahit umabot siya ng ganun kamahal at ang daming delays, ang daming postponement, it's still worth doing kasi it could answer some of our basic questions about the universe, how the universe started, how galaxies form, how planets form, and all that, probably even how life formed kung if we're lucky, di ba? Ganun. So kaya that's why this space telescope is inaabangan ng maraming scientists, inaabangan ng maraming astronomers kung ano yung mga discover niya. So that's why as I said earlier, whatever hype that you heard about this telescope, it's real. Okay, it's so real. Okay, moving on. So, ano yung mga things na makikita ni James Webb? Ano yung mga possible explorations na makukuha natin from James Webb? Its primary aim is to shed light on our cosmic origins. Once again, early formation of the universe, early formation of galaxies and planets, ganyan. And number two, ganun din yung it will observe the universe's first galaxies, reveals the birth of stars and planets, ganyan. Ito yung mga things na madidiscover ni James Webb once fully operational na siya. And then number three, it can look for exoplanets and study, not just look for exoplanets, which by the way, we have like 3,800 exoplanets already discovered. James Webb could study its atmospheres. Pwedeng ma-observe ni James Webb yung atmospheres ng mga planeta na yun. And by observing the atmospheres of those planets, if those atmospheres is anything close to our atmosphere, sa atmosphere ng Earth, then there's potential life dun sa planet na yun. Regardless kung gaano kalayo yung mga planets na yun. We could assume na kung ganyan din yung atmospheres nila, the same as ours dito sa Earth, then we could assume na mayroong life doon. on that planet. So we could be discovering alien life on an exoplanet, on an exosolar system. Yeah. And there are other things na pwedeng ma-discover ni James Webb to cover other scientific research, such as dark matter, dark energy, an update on the expansion of the universe, and so on and so forth. So there's a lot of things to learn from the James Webb. So it's not just about launching the biggest telescope, the most advanced telescope in the world. Hindi lang yung bragging rights. This is not just about bragging rights. It's about discovery. It's about exploration. It's about knowing how the universe works. So they're not just throwing away money. They're not just yung efforts nila is hopefully by the time na it's fully functional, James Webb will discover more of our universe than we already have. Okay. So I want to show you this picture. I don't know if you've seen this picture before. This is actually the first picture na nakuha ni James Webb Space Telescope. And I know it doesn't make sense. It doesn't make sense at all. Pero this is actually the first picture na kinuha ni James Webb Space Telescope. And these pictures are actually a star. Isang star lang to actually. This is just one star. This star is actually found on the constellation ni Ursa Major. If you know about, kung alam niyo yung Big Dipper, ito yung kung nakita niyo yung Big Dipper na ganyan, andito siya sa part ng where yung merong cup na gano'n, may cup part and then may handle. Yung star na yan is actually off the cup part ng Ursa Major, no? This is just one star. Pero bakit ganito ang gulo-gulo? Kasi when the mirror was deployed, when the primary mirror deployed, all those 18 individual mirrors are actually not aligned. So ito yung initial picture niya. Kasi nakita niyo yung hindi siya single image kasi each individual segment is not aligned. So ang gagawin nila, they have to align pa. That's why matagal din bago magkaroon ng official observation si James Webb. Kasi all those individual mirrors has to be aligned. For example, let's say na itong kamay ko isang segment ng mirror. Some of those images are not even andito nakalagay, hindi naka-center. So they have to first center the image sa bawat individual segments. Ganyan. They have to center all that muna. And then they have to focus it. They have to focus the image. And then they have to align all that sa center sa pinaka center ng primary mirror. Ganyan. So once again, let me show you this next image. Ito yung this is the earlier image, pero this time it's labeled by the individual segments ng mirror, no? Nakikita nyo yung label ng bawat segment kung ano yung part which part of the mirror actually it's taking the image, no? Or reflecting the image pala ganyan. So what they are going to do is they will have to align all that. Ito yung left part ng ito yung left part ng deployment ni James Webb. Ito yung right part. Yan. So after that, they have to align it. Yeah, ito naka-align na siya. They all align that. Naka-align na yung mga na-center na nila siya. And then they have to align all that para mag-reflect all the light coming from the star will bounce into the secondary mirror and then back into the center ng As you notice, itong part na to, see this part, medyo hindi siya focused. So they had to focus. So finally, ito yung last slide ko, no. This is my last slide. James Webb actually took a selfie of itself. Dun sa secondary mirror niya kasi, if ito yung primary mirror, yung secondary mirror niya, meron siyang isang camera din doon. that can take pictures of the primary mirror. This way, makikita nila kung if there's something wrong, kung merong basag or merong dumi dun sa mga segments ng mirror niya. And kita nyo yung isang segment dito, merong maliwanag. Isang segment na yan maliwanag. The reason for that is it's reflecting starlight actually. Kaya ganyan ang itsura niyan. Excuse me. So, once again, finally, we get to ask the question. And you get to ask the question. Since you're with your young minds and your curious hearts and your curious minds, you can ask yourself the question. After all this effort, $10 billion ang ginastos para magpadala itong space telescope. Ask yourself the question. Kayo mismo sumagot. Is it worth it? Is this whole endeavor worth the time and effort? Not to mention the money. If I were to answer that question, I'd say yes. Most definitely yes. The more we know about the universe, the more we know about the universe, the more we know who we are and what our place in that universe. Did you know? Bigyan ko kayo ng example. Back then, and this is calling out on sa mga ladies out there who wants to be scientists. And nung time of these discoveries, nobody was thinking na, uy, X-ray, I can use this sa medicine. Uy, microwave, I can use this as a pang-init ng mga pagkain ko. I can also use this in other medical things. They're not thinking that. They're just making discoveries. Wala sa utak nila na magkakaroon sila that this could be useful for anything else. But this is exactly, we are at that point again with the James Webb Space Telescope. But this time, we're looking out. We're looking back in time. And most definitely, if we know more about our universe, we know more about ourselves. Because let's face it, whatever yung those early stars that James Webb all those stars and galaxies na James Webb will observe in the future, those stars was made and died and formed other stars and galaxies to create heavier elements that eventually created us. I mean, inside stars na nabuo ang elements that could create life. Oxygen, sulfur, carbon, and all that. Iron pa, no? All this is inside you. All this is a part of you. So making these discoveries, and making these observations, we not only discover what the universe was, or we also discover ourselves. And looking back, we might even discover ourselves with the James Webb Space Telescope. So the same thing as James Webb took its own selfie, we're also probably be taking observations of who we were and what our place in the universe. So with that, I thank you so much for your time, and maraming salamat ulit for this opportunity. Happy National Astronomy Week, everybody, and good afternoon.
Well, that's about it, mga ka-spacers, about the James Webb Telescope. So, sana marami kayong natutunan about the James Webb Telescope. And I would like to thank Mr. Christopher Lu for accepting our invitation dito sa webinar about the James Webb Telescope in celebration of National Astronomy Week 2022. Maraming salamat din sa mga officers and crew of the Vedan Society of Young Astronomers who hosted the event. And bago pa tayo magtapos sa mga ka-spacers, kung meron po kayong mga questions or reactions or comments dun po sa napanood ninyo about the James Webb Telescope, please type in your comments, your reactions, your questions in our comment section below at sasagutin po namin yan as the soonest possible time. So marami pong salamat, and again, don't forget mga ka-spacers to please like and follow us on our Facebook page, the Vedan Society of Young Astronomers. Like and follow us also on our Facebook page, the Sky Watcher Society of Las Piñas. And please follow me on my Facebook page, the Science Guy Ka-Spacers channel. And don't forget mga Ka-Spacers to subscribe to my YouTube channel, the Science Guy Professor Jun Cajigal. Please click on that notification bell para ma-update kayo sa aking mga future videos. So hanggang dito na lang po tayo mga Ka-Spacers. Maraming salamat sa inyong walang sawang pagtutok dito sa aming programang COSMOQUEST, a podcast. This is your Ka-Spacer and Space Commander Professor Jun Cajigal saying live long and prosper. Always stay safe and always remember to always keep your space. Bye-bye po and see you in our next episode of COSMOQUEST.
8, 7, 6, 5, 4, 3, 2, 1. We have ignition. We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.